Hey guys, Mr. Catlin here. We're looking at our third day of virtual learning, and we're doing handout 3.11 part A today. First things first, please, please, please stop sending me emails about I can't write on the handouts. The handouts, you don't have to type on them. They are for you. If you want to print them and do notes on them, that's fine. If you want to type after the image, this is an image right here, so you can't type in the midst of it. So you could type down here below it if you wanted to take notes of what I'm drawing or what I'm doing in the problem, but you do not have to send this to me. You do not have to share this to me. Please, for the love of God, read the directions. It explicitly tells you that, but here I am explaining it in the video also. All right. Also, if you're having trouble getting to the Zooms, that's also and where all the directions are located. You can find a link for our Zoom there. If you need help with that, send me an email. Get in contact. Don't sit there and do nothing. That's going to be a bad place to be after 2 or 3 days if you've done nothing. All right. So here's our problem for today. We got a goat and a shed. Here's our shed. This is a little box right, y'all. And this dot with a G at the end of it is where our goat is attached at the end of a string. This is cruel. Do not do this to your goat if you have a goat. Don't just tie it on a rope and put it in a shed that it can't even go inside. It's like stuck wandering around this shed, the elements, it's going to get frostbite or something or heat stroke if it's in the summer. I don't know. Let's get past that part. Let's actually do the math here. It's got a 6-foot string that it's attached to, and the floor that's around it, it's and the floor of the shed is a square. The shed's closed. Goat can't go inside the shed. Space everywhere around it is flat, grassy, so the goat is wandering. And we are asked to find the area over which the goat can roam. All right, so it's attached here at the corner of the shed, which I'm going to draw a picture here that kind of helps me see this. So from that shed, it can go down 6 feet this way, which is right about there. And from this corner, it can go over 6 feet this way. So that gives the goat roamage in this circle area right here, which looks like a upside down Pac-Man. All right. So the first thing that I'm going to write down is that 3/4 of the area of a circle with radius equal to 6. You see that? I've got a circle that has a radius of 6, and it's only 3/4 of the area because of the shed is blocking us off. When that rope arrives at this corner, it goes down, it's not going to be able to continue this pattern and close off this circle. The shed is going to have a different effect. When that corner hits, we have a new circle that creates a new pattern that has a new radius. And whenever that rope hits that corner, it's only going to be allowed to go this far. And the same thing over here. It's only because that corner is going to cut it off. It's going to create like this little quarter circle section, right? So the blue is 3/4 area of a circle with a radius of 6. The red little area here that I just drew has a radius of 3, which I just covered up, and it's only a quarter of circles. But there's 2 of them. There's 2 quarters. So what I want to write down is that's the half of an area of a circle with a radius of 3. So I need to find areas of circles of radius 6 and radius 3. So let's call Dr. Dr. Rico for some assistance in this regard. All right, so set up our table, call Dr. Rico right away. Circumference is not going to be anything we're going to worry about. We don't even have to worry about the diameter here because we're given the radius. So we have a radius of 6 and we have a radius of 3. So squaring those, we'll have 6 times 6 is 36. 3 times 3 is 9. So the blue, actually, let me do this in blue. The full area. Now, remember, these are full areas. The full area of the blue circle that we have over here is 36 pi, right? And the full area of the little red circle that's created in this quarter is 9 times pi, which is 9 pi, Okay, we get those areas by simply multiplying by pi. We could multiply by pi and get a decimal, but we're going to leave it in terms of pi. Okay, and so what we're going to do is we don't want that full area. We don't want that full area. We only want half of this one. We only want 3/4 of that one. So I'm going to write it down like this. I want 3/4 of 36 pi. That represents everything that's blue. Plus, I want 1/2 of 9 pi because that is everything that is red. It's a half circle, so half of that 9 pi area. So the way that this boils down, the way that this shakes out is we just got to find 3/4 of 36. So if I broke 36 up into quarters, that would be 9. We want to keep 3 of those. So this is the same as 27 pi. Looks like I need to spray down the desk for the end of class. That's different. Okay, so half of 9 pi, that's going to be just half of 9, which is 4.5 pi. So all we have to do is add 27 pi plus 4.5 pi. And since they're both pi terms, all we have to do is add 27 plus 4.5. And that gives us 31.5. So this is, our answer is 31.5 pi, or times pi. And I can do that on my handy dandy calculator here. 31.5 times 3.14. That's GOAT there has himself about 98.91 square feet to roam. Not a lot of space for the goat. It's cut off. It's wandering around 3/4 of this shed and these little quarter circles on the other side, going, man, let me go. Right? It needs to get free. We need to give this goat some relief. But that's how you do a very difficult problem with half circles, quarter circles, 3/4 circles, but using our Dr. Rico situation there. All right, there's your lesson for the day. See you guys later.